Statistics and probability. Problem 5. Find the probability of rolling doubles on a two six-sided dice numbered 1 to 6. Okay. What does it mean in this problem? Well, it's asking us to find the probability of what? It's trying to ask about finding the probability of rolling doubles on two six-sided dice numbered 1 to 6. Okay. So rolling doubles is when you roll two numbers and then the two numbers you get are the same. So one type of double could be you get a 1 on the first dice, a 1 on the second dice, or 2 on the first dice, 2 on the second dice. Anyway, the dice has to be the same. And it's two six-sided dice numbered 1 to 6. That kind of normal dice that you usually see. Okay. Now, what's our first step right here? Well, we're trying to find the probability. So we're trying to find all the number of how much possibilities there are. Right now, we're not even talking about rolling any doubles. We're just going to talk about how many types of rolls can we roll. Well, I'm going to make a table right here. On the top would be dice number 1. On the bottom, actually on the side, would be dice 2. And what I'm going to do here is I'm going to make a grid for all of the possible possibilities. Actually, you know what? Yeah. So let's first not make the grid. I just want to ask you something. How much possibilities are there? Well, imagine that grid. On the top, it would be 1, 2, 3, 4, 5, 6. On the side, it will also be 1, 2, 3, 4, 5, 6. And we're going to break this up into different grids. This is really bad right now, but pretend some sort of grid like this. In each of these grids, I'm going to rate that possibility. For example, over here, this is dice 2. This is on the side here, it's dice 2. This is dice 1. So it would be like that because it got a 2 on the first roll and a 1 on the second roll. Over here, it would be a 2 on the first row, and since this is 2 right here, the second row, we would also get a 2. So imagine all of this. For example, here would be 1, 5, 1, and that. This is really bad. We're not just wanting to get a sense of what it might look like. What it will look like, actually. So you got the hang of that. And now we're gonna try to just think about how much possibilities there are. I mean, right, I'm clearing this out just for space. Because there's 6 values on the top row, and there's 6 values on the left side of the grid. And what's this forming right now? You got it. It's an array. One of those multiplication arrays that you were working with very earlier on. It's an array, and it's actually a 6 by 6 array. 6 by 6 array. So, if it's 6 by 6 array, we do 6 times 6, that's 36. The number of how much possibilities there are shown on the grid. So that's going to be our denominator. Then let me ask you, what are the doubles? What are the possibilities of doubles we can get? Well, it's doubles, and each dice is only from 1 to 6. So it would be 1 and a 1, a 2 and a 2, a 3 and a 3, a 3 and a 3, a 4 and a 4, a 5 and a 5, and finally a 6 and a 6. And we can't go further on than that because there is no 7 at all. It's It's a two-sided dice numbered 1 to 6. So how much of these possibilities do we have out of the 36 possibilities there are? 1, 2, 3, 4, 5, 6. So the top number would be 6. So that's our answer, right? Well, no, it depends. Usually in some tests or in some problems, they require you to simplify the fractions, others don't, but it's always a good idea to practice to simplify a fraction. So right now, what is 6 over 36? It's the same as 1/6. So the answer is 1/6. There is 1/6 of the probability that you can roll a double on a two-sided dice numbered 1 to 6.